Hey there, CS210 students. So in this recording, we're going to talk about copy constructors and finalize the idea of destructor and properly deleting out our objects. So we're going to scroll down here. So the idea of a copy constructor is a constructor that gets called when an object of the class type is passed by value to a function. So we can copy the values during that execution. So an example might be we have a variable class object 2. We're assigning it class object 1. So what we want to do is by default, we want to copy what this contains, and we want to do what's called a deep copy. So any members, including pointers, get their own references in a deep copy. Otherwise, if we just copy over an object by copying their values, we create what's called a shallow copy. Now, shallow copies are fine for some classes, but typically a deep copy is desired for objects that have data members pointing to dynamically allocated memory. Because the idea here is if you have a shared pointer and if you delete out some things, you might not actually delete everything in it. So the idea of a copy constructor is we're going to create a constructor, again, it's always the same name as the class. We're going to go const a reference to the original object. So const means we can't reassign this object here, but we can reference what it contains and then copy over its values to our new class. So they come down here. So in this class, we have a private int pointer for some data object. And so in the copy constructor here, you can see that they pass in the original object. It's going to get passed in. And then data object gets a new int. So we have reallocated new memory for our new instance. And then we're going to assign. So remember, using the dereferencing notation here, we're going to assign what data object gets by grabbing the original object that got passed in, its data object, and we have to dereference that as well. So this is going to create a deep copy of what is contained from this object. So we would need to do this process for every deep not deep, for every pointer type reference in our private member variables. Now, they also provide then a destructor. So we have a destructor here. So they are then calling the delete data object right here. So we're deleting out this memory on the destructor. So if we come down here and run this, we create a temporary class object. We set it to a 9. And so before, this is going to be a 9 here. And then this is where that deep copy is so powerful. When I pass in my temp class object, we get a copy. So this is going to create a copy of temp class object. And so in here, this would have created a copy. And if we don't have this deep constructor, this deep copy constructor, then our initial would have been changed. Now this is going to stay what it was before. We passed a copy of what it was and we didn't pass the original. So we should always have a copy constructor that creates a deep copy of our object. So again, they kind of talk here. So this one's pretty simple, but if we have a class that has multiple data members, data objects whose types are pointers, you always need to have a copy constructor, okay? So they kind of walk you through that in these other exercises. So a little more detail. So the copy assignment operator. So given two class objects, we might write something like class object 2 equals class object 1 to copy the class object 1 to class object 2. The default behavior of the assignment operator, though, is to perform member-wise assignment. So what that does is it may work fine for basic types like ints and characters, but it does not work properly for pointers, okay? And again, they're going to walk you through how that issue comes about. So always keep in mind, we should have a copy constructor that is going to copy all of these pointer type values. So we might overload the assignment operator in that case. So we can come down here and we see that they've declared the overriding of the assignment operator here, and then in the implementation, basically they're going to perform the same action as we did with the copy constructor. So this makes sure that we always have a new reference when we are copying a reference. Okay, last section, we talk about in C++ the rule of three. So a good C++ programmer, when they create their own class, is going to have these three functions commonly implemented together. So you're going to have a destructor that is automatically called when the object gets destroyed using the delete keyword. And remember, this needs to delete any pointer reference, needs to delete all allocated memory. If you don't delete all the allocated memory in the destructor, then you've left a memory leak behind. We're going to have a copy constructor. Again, we saw that in section 10.9. We're also going to have a copy assignment operator that we see right here in 10.10. So we're going to override the assignment operator. So that rule of three is a good practice for any class that you create. If you do this properly, then your class can be utilized anywhere and people know that it's not going to produce any memory leaks and it's not going to have any invalid data as it's worked with. Okay, so that's going to do it for this recording. I will talk to you next time.